After a week of tension between SpaceX and NASA, things have taken an unexpected turn. The private company quickly released a series of updates on the HLS program, clear proof that Starship's development is still right on schedule. That move quickly restored public confidence and even left NASA's acting administrator with no choice but to walk back his earlier remarks. So, how far has the HLS program actually come? And can SpaceX really deliver in time for the 2027 Artemis 3 mission? Let's find out in today's episode of Alpha Tech. As anyone following recent news already knows, the tension between SpaceX and NASA began when acting administrator Sean Duffy openly criticized Elon Musk's company on Fox News. He argued that SpaceX's progress might not be fast enough to stay on schedule, raising concerns that the United States could lose its lead in lunar exploration to China. Yeah, his concern really makes sense. But the problem is, he made a big mistake by provoking Elon Musk, especially by bringing Blue Origin into the conversation, and even suggesting that NASA should be merged under the Department of Transportation. The situation became so tense that officials at the White House reportedly expressed frustration, saying they're tired and increasingly impatient with Duffy's ongoing feud with Musk, a controversy they see as completely unnecessary. And honestly, it's not hard to see whose side they're on. Musk isn't just rich, he's insanely influential. He owns X, dominates the conversation on social media, and his voice easily reaches millions through mainstream outlets too. With that kind of reach, Musk could literally help shape public opinion heading into the 2026 midterm elections. But here's the thing, it doesn't really matter who's backing Musk or how powerful his influence is. At the end of the day, both he and SpaceX still need to prove that Starship HLS is actually making real progress and staying on schedule. Because without real progress, all that support means nothing. And well, it looks like they've just done exactly that. Just a few days ago, on October 23rd, barely 3 days after the whole drama broke out, something really strange was spotted at Starbase. At the production site, workers were seen moving a massive, never-before-seen steel structure. It looked kind of like a Starship nose cone, except without the tip. But here's the thing, it definitely wasn't a part of Starship. The structure had a grid of perfectly cut square openings across its surface, all neatly aligned, and a temporary metal bar welded on the side, probably to keep it from warping during transport. That's when speculation exploded online. Many believe this could be the crew compartment for the Starship HLS, since the section appeared huge, around 9 meters in diameter, and those square cutouts could very well be window openings. However, others pointed out that the layout didn't match any of the official HLS renders. The number and placement of windows seemed off way too many at multiple heights, and even overlapping. So, the more likely explanation is that this is just a manufacturing test article, a mock-up to study how to cut and reinforce window openings in stainless steel. But then again, if it's just a test piece, why would they reinforce the openings with metal bars like that? Either way, it's a clear sign that SpaceX is actively working on HLS hardware right in the middle of all this NASA drama. This isn't the first time SpaceX has dropped clues like this. They've done it before, several times actually. For example, remember the airlock module that was spotted inside the Star Factory late last year? It literally had a sign on it that read HLS airlock. The design looked super modern, compact, and functional, clearly built with a refined approach to how astronauts will access the lunar surface. That same module appeared almost identical to the one seen integrated into the nose cone of the HLS prototype at Starbase in 2024. And it didn't stop there. We've also seen what looked like the HLS crew seats inside the Star Factory seats that closely resemble those used in Crew Dragon capsules. Plus, earlier elevator tests already hinted at how astronauts will move between Starship's cabin and the lunar surface. All of this points to one thing: SpaceX hasn't been slacking off on the HLS program at all. In fact, they've been quietly making steady progress, possibly leading up to a major reveal later this year. It's entirely possible that SpaceX could announce the completion of the first full HLS assembly and begin preparing for a test flight sometime in 2026. After all assembling, a Starship doesn't actually take that long. The real work is in optimizing it for the new Super Heavy version 3. And yes, HLS will fly on a Super Heavy booster. The only remaining booster right now is B-17. It's still sitting quietly in the rocket garden, unused since Flight 11 flew with Booster 15 instead. For whatever reason, B-17 was skipped, and that makes it unlikely to be used for HLS. So the timeline for HLS will now partly depend on how quickly SpaceX can roll out the upgraded version 3 boosters. They'll also need to adapt the HLS aft section to fit the newly designed hot staging ring of the Super Heavy V3. After all, HLS was originally designed back in 2021, and a lot has changed since then. And guess what? SpaceX just gave us a clue about when they plan to attempt that first orbital refueling test. This became clear when engineers at Starbase were spotted working on Ship 39, the very first Starship V3 vehicle inside Mega Bay 1. Cameras there accidentally caught something unusual, 2 strange ports built into the nose cone section. They're located fairly low on the structure, and this time, it's not speculation. These are definitely part of the orbital refueling system. Their appearance perfectly lines up with SpaceX's transition to Starship version 3, which will define the next major phase in 2026. And just last month, Elon Musk himself confirmed it, saying SpaceX will do orbital refilling several times next year with Starship V3. He added, "Because we're simply docking with ourselves, this is a much easier problem than docking with the space station, which SpaceX already does several times a year." So, yeah, no doubt about it. The 2 new ports on Ship 39 mean SpaceX is preparing for a bold orbital refilling mission next year. The only real question is whether they'll do it with the actual HLS or a dedicated test vehicle. But odds are we'll see HLS involved at some stage. Now, the big question is when exactly. According to the current internal timeline, SpaceX first needs to reach orbit successfully and catch a returning Starship with Mechazilla. Those 2 milestones are expected around Flight 12 and Flight 13 if things go as planned. After that, several more test flights will follow before they can safely attempt an orbital refilling mission. If that mission ends up involving HLS, it would require 2 launch pads operating simultaneously, most likely HLS launching from LC-39A in Florida and the tanker from Starbase in Texas. Based on progress so far, this daring double launch could happen around Flight 17 to Flight 20, sometime between June and August 2026. With the clock ticking toward Artemis 3, SpaceX must soon move from design to demonstration. A full-scale refueling test, visible to the world, will be the ultimate proof that they're ready not just for NASA, but for history. So, are you excited to witness that historic moment? If you are, drop a Go SpaceX in the comments to show your excitement and support. If SpaceX can pull all of this off, the US will firmly maintain its leadership in this new lunar era, and humanity will stand at the threshold of a sustainable presence on the moon. But in the short term, these recent updates SpaceX strategically revealed seem aimed at calming rising tensions with NASA. Because while NASA and SpaceX are tangled in disagreements over contracts and exploration timelines, China has been quietly advancing its own ambitious commercial space industry. At the center of attention is Zhuke-3 Landspace's reusable rocket, which just completed a crucial static fire test at the Jiuquan Satellite Launch Center right around the same time Elon Musk and Sean Duffy were arguing. Even Musk couldn't ignore it, saying they have added aspects of Starship such as use of stainless steel and methalox to a Falcon 9 architecture, which would enable it to beat Falcon 9. With 9 methalox-fueled Tianqi 12A engines and a stainless steel body, Zhuke-3 blends the designs of Falcon 9 and Starship. And that's exactly why Musk himself admitted it could one day outperform Falcon 9. Its first flight, planned for November 2025, will not only deliver satellites to low Earth orbit, but also attempt booster recovery, a revolutionary move for China. But don't get it twisted. Musk's praise for Zhuke-3 wasn't really about giving China credit. It was a way to highlight just how far ahead SpaceX still is. Shortly after that compliment, he clarified, it will take them over 5 years to reach Falcon 9 levels of reliability and production launch rate, by which time SpaceX will have transitioned to Starship and be doing over 100 times the annual payload to orbit of Falcon. So, in the end, no matter how impressive Zhuke-3 looks right now, SpaceX is still playing in an entirely different league, one that could keep the US firmly on top for decades to come. Starship could deliver 100 gigawatt per year to high Earth orbit within 4 to 5 years if we can solve the other parts of the equation. "I can't wait to go to the moon." Those were the confident words from SpaceX's top leaders, Elon Musk and Gwynne Shotwell, after weeks of heated back and forth between SpaceX and NASA, or more precisely, between Elon, acting administrator Sean Duffy, and former administrator Jim Bridenstine. Both NASA officials had been openly criticizing SpaceX for its delays. But just a few days ago, SpaceX dropped a massive update packed with new details and hard data about the Starship HLS. And let's just say, it completely silenced the critics, while giving us the clearest picture yet of just how extraordinary this lunar vehicle truly is. It all started on September 30th, when SpaceX suddenly dropped a rather cryptic post. In it, they stated that Starship will always be the fastest path to return humans to the lunar surface, and that it's the core element driving NASA's Artemis goal of establishing a long-term, sustainable presence on the moon. The post included a link to SpaceX's website, where they laid out every detail of their lunar mission progress, and it was pretty clear this was SpaceX's counterattack to all the criticism they'd been facing. Before we dive into the update itself, let's take a look at the 4 official renders SpaceX released alongside the post, giving us our first real glimpse at the latest design of the HLS vehicle. Alright, this is the Starship HLS, seen here docked with the Super Heavy booster at the launch tower moments before liftoff. Take a look at the hot staging ring on the booster. That's the brand new booster version 3 design. So it's almost certain that HLS will launch atop this upgraded booster sometime in 2026. As for the HLS itself, its exterior doesn't look all that different from the earlier concept renders. Yes, it has 4 landing legs, but their design is completely different from Falcon 9's. Falcon 9's legs are optimized for flat and stable surfaces, while the HLS legs are built specifically for the uneven terrain of the moon. Shorter, sturdier, and positioned to keep the vehicle's center of gravity low and stable during touchdown. The entire body is painted in that familiar white coating, which helps reflect sunlight and radiation in the harsh environment of space. Near the nose cone, there's a black strip. And no, it's not just a decorative detail. It's actually part of the hot gas thruster system, designed to precisely control the vehicle's attitude and assist with a smooth, controlled landing on the lunar surface. This dark band either covers or marks the location of the thruster nozzles and gas lines, helping to minimize how much lunar regolith gets blasted away compared to firing the main Raptor engines during descent. Just a few meters above that, you'll spot a row of 10 small rounded windows, giving us a peek at the crew compartment behind them, the area where the 4 astronauts will live and work during their lunar mission. Inside, the crew cabin is positioned on an upper level, accessible by ladders, and connected through a tiered interior layout. At the very top is the docking port, the interface for connecting with Orion, not a secondary fuel tank like on the standard Starship version. According to SpaceX, one single Starship has a pressurized habitable volume of more than 600 cubic meters, roughly 2/3 the pressurized volume of the entire International Space Station, and is complete with a cabin that can be scaled for large numbers of explorers and dual airlocks for surface exploration. And as Elon Musk himself once said, Starship is designed to carry 100 people. That number sounds absolutely insane, 100 people on a single spacecraft. Of course, SpaceX isn't aiming to send that many anytime soon. For now, the lunar variant will likely carry only 4 to 12 astronauts. And really, just 2 or 3 missions with that many crew members would already be enough to kickstart Musk's grand vision. Because as he also said, Starship will build Moonbase Alpha. To make that possible, Starship HLS is equipped with 2 dual airlocks in its lower section, one dedicated to EVA operations and another as a backup. Each airlock is built from advanced composite materials with airtight seals to prevent gas leakage. Inside, the spacecraft is fitted with a sophisticated environmental control and life support system, or ECLSS, capable of recycling water from urine and sweat, circulating oxygen and nitrogen through the cabin, and maintaining a comfortable internal temperature between 20 and 25 degrees Celsius. And yes, there's even an elevator system to carry astronauts from the crew cabin down to the lunar surface, about 50 meters below. This platform uses composite cables and electric motors, capable of safely transporting 2 to 4 crew members along with their equipment. It's equipped with handrails and anti-jamming sensors, ensuring smooth and safe operation. At the very bottom, the elevator integrates directly with the airlock system, allowing astronauts to step out onto the moon's surface safely, instead of having to jump out of a hatch like some early concepts suggested. And according to SpaceX, these systems have already been tested with NASA astronauts long before this reveal. But that elevator is just one of the 49 milestones SpaceX has achieved in developing the many subsystems, infrastructure, and operations needed to get astronauts to the moon. These include everything from docking tests between Orion and HLS to landing leg trials on simulated lunar soil and countless other technical validations. SpaceX emphasized that the vast majority of these milestones have been achieved on time or even ahead of schedule. So clearly the criticisms about delays are largely unfounded. And when it comes to cost, SpaceX made something else very clear. They're funding over 90% of the entire Starship program themselves, including the core Starship system and all of its variants like the HLS. The $2.89 billion NASA contract covers only a small part of it. In total, SpaceX's self-funded investment in Starship is estimated to be around $5.4 to $7.2 billion. In other words, the NASA contract is just a drop in the bucket compared to what SpaceX is putting in. Meanwhile, critics often forget that SLS, which began development a full decade earlier, has already cost U.S. taxpayers roughly $29 billion just for the rocket itself, not including the mobile launch platform or the Orion spacecraft. So when you compare the timelines, the costs, and the progress, it's pretty clear who's really pushing humanity forward more efficiently. Besides the HLS, the update also included two other Starship variants, the depot and the tanker. These are the core components of SpaceX's orbital refueling architecture, working hand in hand with HLS to make missions to the moon and eventually Mars possible. Let's start with the Starship tanker. Since it's optimized for reuse to keep launch costs low, its exterior looks almost identical to a standard Starship, featuring the same aft and forward flaps, as well as the ceramic heat shield system. The key difference is inside. Instead of a payload bay, most of the interior is taken up by massive fuel tanks. Built on the Starship version 3 platform, the Tanker V3 is designed to carry up to 1,200 tons of methalox propellant. It also features large fuel transfer ports along its midsection, enabling quick and efficient docking with the Starship depot. Now the depot variant is a completely different vehicle. It's basically a giant propellant storage ship designed purely for on-orbit operations. There are no flaps, no heat shield, and no need for aerodynamic control, just a clean, optimized structure where the fuel tanks occupy nearly the entire internal volume. It's powered by 6 Raptor engines and features 4 refueling ports near the top, allowing it to receive fuel from multiple tanker flights. In essence, it's a floating fuel station, built to stay in orbit indefinitely, never returning to Earth. Its sole purpose, to keep the HLS and other Starships topped up for their journeys beyond Earth's orbit. Thanks to the depot, the number of tanker flights needed to fully refuel an HLS mission will drop to just around 10 launches, greatly improving both efficiency and safety. In other words, about 2 to 3 weeks before the Artemis 3 mission, we'll likely see a rapid cadence of Starship tanker launches, each lifting off, transferring fuel to the depot, then returning to Mechazilla for reuse. And when launch day finally arrives, the HLS Starship will lift off, dock with the depot, and begin the refueling process, which takes roughly 1 to 2 hours. Once fully fueled, it will then depart directly for lunar orbit, where NASA's Orion spacecraft will already be waiting. After docking with Orion, the astronauts will transfer into the HLS, and from there, begin their historic descent to the moon's surface. But that's still a vision of the future, a moment when all 3 variants, HLS, depot, and tanker, are fully operational and working in harmony. So, what exactly does SpaceX need to do to get there? Well, the next key milestones for the HLS program include a long-duration flight test and an on-orbit propellant transfer demonstration. The exact timing depends on the progress of upcoming Starship test flights, which will introduce the new version 3 architecture. Both of these critical tests are expected to take place sometime in 2026. The orbital refueling capability is what will truly complete the Starship Artemis mission architecture. It will allow the vehicle to carry up to 100 tons of cargo, directly to the lunar surface, including rovers, habitats, and other payloads necessary for establishing a sustainable human presence on the Moon. The campaign will begin with one Starship launched from Starbase for an extended mission in Earth orbit. This flight will collect data on the vehicle's propulsion and thermal behavior over time, including long-term cryogenic fuel storage and boil-off characteristics. Then, a second Starship will launch to rendezvous with the first one to demonstrate in-space propellant transfer from one ship to another. The new Starship V3 vehicles will feature dedicated refueling interfaces, allowing them to act as tankers when equipped with additional probe connectors. Even the ground fueling ports have been redesigned to support in-orbit refueling operations. To make the rendezvous possible, Starship will rely on Dragon Eye navigation sensors, a proven system that SpaceX has used for years on its Dragon spacecraft during dozens of successful dockings with the ISS. These sensors have already undergone separate tests to validate their performance when integrated with Starship. Additionally, SpaceX has been flying experimental propellant mass sensors on every recent Starship test flight. These use radio frequency measurements to precisely track the amount of fuel remaining under microgravity conditions. In simple terms, proving this highly complex technology will require multiple incremental tests. And that's why achieving a stable and reliable Starship V3 is the core foundation before anything else can move forward. So, are you excited to see that day come sooner? If you are, drop a Go SpaceX, Go HLS in the comments to show your support.